Hi, this is Ramesh, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science. In this lecture video, we are going to discuss about formulation of linear programming problem from quantitative techniques. First of all, what is the meaning of linear programming problem? Programming. So what is programming? Programming means planning. All the relationship between the variables consider these problems are linear. Therefore, we call it as linear programming problem. So what is the general form of linear programming problem? So it has optimum, either maximum or minimum is that is c1x1 plus c2x2 plus c3x3 plus etc. cnxn is called objective function or cost function, subject to the constraints a11x1 plus a12x2 plus etc. a1nxn either less than or equal or greater than b1. Similarly, we have a n1x1 plus a n2x2 etc. plus a nmxn either less than or equal or greater than or equal to bn. These are all called constraints. Finally, all the decision variables x1, x2, etc., xn are positive. So these are all the general form of linear programming problem. So what's the purpose here? The problem to determine the value of n variable x1, x2, etc., xn, which makes z as maximum or minimum as required in subject to the constraints and the non-negative conditions. So how formulate the given problem as LPP? We follow the following steps. Step 1, identify how many decision variables. Step 2, write down the objective functions to be optimized, either maximized or minimized as a linear functions of the cost of coefficients. Step 3, note the constraints on the basis of the conditions specify recording availability of time, demand of the product, etc. Step 4, mention the non-negativity restrictions which imply the decision function, the decision variables. So now we discuss one example on how formulate a given problem as LPP. Consider this problem. A firm manufactures two types of products A and B and sells them at a profit of rupees 2 on type A and rupees 3 on type B. Each product is processed on two machines M1 and M2. Type A requires 1 minute of processing time on M1, M2 machine, M2 minutes of M2. Type B requires 1 minute on M1 and 1 minute on M2. Machine M1 is available for not more than 6 hours 40 minutes, while machine 2 is available for 10 hours during any working day. Formulate the problem as LPP so as to maximize the profit. So first we identify how many decision variables. So let that decide the product we produce x1 unit of product A and the x2 unit of product B to maximize its profit. Therefore, the decision variables are two. One is x1, another is x2. So to produce these units of type A and B products, it requires x1 plus x2 processing minutes on M1 and 2x1 plus x2 processing minutes on M2. Since machine 1 is available for not more than 6 hours 40 minutes, we convert everything as their minutes. So 6 hours, 6 into 40 is equal to 240 into 6 into 4 is 240 plus 40 minutes. B is available 10 hours during any working time. Therefore, the constraints are x1 plus x2 is less than or equal to 400. So 2x1 plus x2 less than or equal to 600 and x1 x2 greater than or equal to 0. Since the profit from type A is rupees 2 and type B is rupees 3. Therefore, the total profit is 2x1 plus 3x2. So the objective of this LPP is maximum the profit. Therefore, the objective function is maximize z is 2x1 plus 3x2. So finally, we have the required LPP maximum z is 2x1 plus 3x2 subject to the constraints x1 plus x2 less than or equal to 400, 2x1 plus x2 less than or equal to 600, and x1 x2 are greater than or equal to 0. We consider one more example. A company makes two types of the leather product A and B. Product A is up quality, high quality, and the product B is lower quality. The profit of each product is rupees 4 and 5. Each product A requires twice as much time as product B, and it all product were of type B. The company could make 1000 per day. The supply of leather is sufficient for only 800 products per day, both A and B combined. So product A has special spare parts and only 400 per day are available. These are all. There are 700 special spare parts a day available for product B. Formulate these all everything as LPP. So first we identify how many decision variables. Here we produce there are two products. Therefore, x1 and x2 are two decision variables to make the maximize its profit. So we have this type of table. The supply of leather is type A is 1 and type B is 1. It is not more than 800. The time duration is product A is 2. The time durations for product B is 1 minutes. So these two are produced not much more than 1000 hours, 1000 units. The special parts A is available, it is only 400, therefore it is less than or equal to 400, and the special parts for B is also there, it is 100. So the company decided the product X1 units of product A and X2 units of product B maximum to its profit. So objective function is maximum is that is 4x1 plus 5x2. Therefore the required LPP is maximum is equal to 4x1 plus 5x2 subject to the constraints 2x1 plus x2 less than or equal to 1000, x1 plus x2 less than or equal to 800, x1 is less than or equal to 400, x2 is less than or equal to 700, and x1 x2 are positive. Thank you.